Okay, there we are.
Jim, you with me?
Yes, I am.
All right. Good morning, everybody. John Resso, Wells Darby, Jim DePalma, Wells Darby in the background. We're going to go through the NTI GF200 today and the NTI TRX boilers today. At the lower side of your screen on the right-hand side, you'll see a column that has questions. If you have any question throughout the presentation, just click on that, open it up, and you can ask a question. Either Jim or myself will be ready to answer the questions throughout the presentation. We appreciate everyone's time, and we will start right here. So the GF200 with green furnace technology, what is it? It is a Combi furnace. That's a different word, Combi furnace. Usually we say Combi boiler. This is the North America's first Combi furnace. We meet Energy Star, Low NOx, AHRI certified, and all the plumbing certifications also. So pretty unique product. So truly, what is it? Well, it's a water heater in the front, and it's a Navien water heater. It's an on-demand water heater, tankless water heater, however you guys refer to them. So NTI has taken that product. They've added in an NTI controller and an NTI three-way valve and an NTI flow switch. And we have added to the back side of it, so it's hot water in the front and it's HVAC in the rear. So we've added a blower, a hopper, and a hydronic coil. So you would look at that as a typical air handler type deal, hydrocoil unit. So we have the ability here with the tankless water heater to produce hot water for the home and to produce heating for the house. So if you look at a typical home, let's say it's a typical 2,000 square foot home, 2-story, 3-bedroom, 2.5 bath, pretty common, right? Ballpark 40,000 BTU, depending on the envelope of the home. 2.5 ton worth of air conditioning, no problem. This is a direct replacement for a system like that. And we'll dive into the details of what the Combi furnace is capable of here as we go through the program. So range and ratios here, whether it's a retrofit or a new construction project, you're going to be somewhere in the ballpark of the 850 to 3,000 square foot home. The blower has the capacity in the heating cycle. It has 10 stages of blower capacity. So we'll talk a little bit more about the blower later in the program, but it basically has the ability to learn and understand what the home is looking for at any given time. So this is where the blower will learn the house. It will adjust as it needs to adjust to support the heating demand within the home and move the proper amount of air at any given time. You also have the ability in cooling to have 2 different stages of cooling. And there's preset ranges on the controller for your 2-stage cooling. That is adjustable. So if you have a 2-stage condenser outside and you want to tie it directly into this unit, you have the ability to do that, and you can match the CFM for the stages of the outdoor unit. So from a domestic hot water standpoint, again, it's a Navien water heater, tankless water heater. We can handle between 2 and 3 standard bathrooms with tubs. Venting, 2-inch PVC up to 60 feet, 3-inch PVC up to 150 feet. So we're briefly going over this, and in your mind, you're already asking yourself, why? Well, here's a couple of the advantages of why. If it's a new project, it's 1 gas line, 1 vent system, 1 electric circuit. So that means you have space savings. You can get heat and hot water out of 1 unit. Okay, if it's a retrofit, depending on what the homeowner is looking for, if you're there to change the furnace and they already have a water heater that is hit its 7 to 10 year cycle life, you have the ability to offer them 1 unit that will handle the heating, cooling, and the hot water for the home So a lot of flexibility. The hot water can be taken off the left or the right-hand side. So that makes it convenient for plumbing. The 2-inch vent is right there off the front, right behind the NTI logo. And the control is directly in the center of the front cover. Your air flows out of the top, and we'll go through your options for return air. So again, one unit, we can do 3 different things with one unit. Yes, it is a variable speed condensing unit, and we'll dive into that deeper. So the overall size, it's 38 inches tall, 38 inches wide, or long, I should say, 17 3/4 inches wide. It weighs about 248 pounds. You got a B box takeoff for the supply. So if you're putting a AC coil on the top, it'll be a B style. And then you have on the left side and the right side, you have a 20 by 20 return air grill that cuts into the door. It can also be back or bottom for your return air. It will deliver simultaneous hot water and heating until the unit reaches 170,000 BTU. Once it gets to 170,000 BTU, it will automatically prioritize the hot water, and it will continue to drive itself up to the 199,000 BTU of input that it's capable of. Okay, so we have a combination furnace with 97.1% efficiency. So the Energy Star, the rebates that are available, everything that's out there that's available as far as dollars back to the homeowner because of that 97.1% efficiency rating, that really helps when you're proposing a new installation or a retrofit installation, and the homeowner sees the opportunity to save some money with the rebates that are available. So this is a Navien tankless water heater, condensing tankless water heater. They basically purchase it from Navien. It goes into the cabinet of the GF200. It's bolted in. The Navien sticker is still on the side. That is shown through the side of the cabinet. The Navien manual comes with the unit, and the NTI manual comes with the unit. So NTI is not trying to hide anything. They're not, this is truly a Navien product in the front, and NTI has taken that Navien product and tied it into a coil and made it a furnace. So it's a hot water and furnace all in one.
Excuse me a second, John. One question that did come through, and I wasn't 100% sure how to answer it, was can they get parts for the Navien side of it directly from Navien, or would they have to go through NTI?
No, that's a great question. So everything will come through Navien. Even if you're troubleshooting the Navien portion of it, that'll come through Navien. NTI can help you with that, but the control is an NTI control. The 3-way valve is a NTI control, but a standard part on an NPE 240A, every part that's on that is Navien. So you got your stainless steel primary heat exchanger, your stainless steel secondary heat exchanger, you have your negative pressure gas valve, everything about the installation manual, any way you set up a Navien, this is the way that this unit will be set up. Yes, propane is an option. It's standard for conversion. No problem there. It can be natural or propane. That was a question, Jim, that came across. I just seen.
Just saw it.
Okay, so it's highly recommended, and we really don't want to see it any other way, is to have a mix valve. And the reason behind the mix valve is we need to make sure that we can support the hot water that the house needs and support the hot water that the coil needs to support the BTU within the home. So this can be piped right or left. You see there the door is off. So the metal here is pretty thick. So if you're going to cut a return air takeoff in here, this is a good spot. So you have the door missing. You take the door out. There's knockouts there. The door is thick. It's going to take quite a bit to cut it. So there's a door switch on these. Some guys will remove the door and then they'll put the return air right up against the side of the furnace. But there's a door switch on the right and the left-hand side. So if you don't cut your return air grill in, you just remove the door. Now you have a door switch. It's not going to allow the unit to run. So I just want to point that out so everybody is aware of it. So you don't get it out to the job site and find out that, you know, it won't run after you do it. So be aware of that. The piping, again, right or left side. Right below the arrow, let me just show you one thing here, because this is something you have to install on the job. So here's the mix valve. This right here, this is a flow switch. And what that does is that recognizes the flow that the unit, you know, and tells the unit that there's flow going to the tankless water heater. Based on that flow switch signal, that's what will tell the tankless water heater to fire up, and it will take off and run. If you're using hot water, it's going to produce the hot water. It's going to send the hot water out. If we get to higher flow rates, again, this will prioritize hot water. When it gets to about 170,000 BTU, it will reduce the heat, knock it off, and divert all the power that the burner's producing, all the BTU that the burner's producing, and drive that hot water demand to where you need it to go. So that's key, very important. There's that right there that you're seeing on the side of the unit with the mix valve and everything. NTI sells that as a kit. So you would just take and plug in your adapters to the right or left hand side. There's a clip on the inside to clip them in place. You would do your soldering before you clip them in, because there is a rubber O-ring. So you'll solder your pipe in, put them into the side of the unit, put your clips on, and hang your hot and cold water outlet to the house. Okay, let's go here. Okay, so from the heating side, it is 20,000 BTU. It modulates down, so we can modulate down to 20,000 BTU. And when it modulates up, we can produce up to 80,000 BTU worth of heating capacity. So it's self-learning 10-stage modulating blower on the heating system. So it has PDI technology built in, so it will start to learn and understand what the home needs, and it will automatically adjust the airflow to support what the homeowner needs. So we have up to 1200 CFM airflow for heating. The return air grill, again, it can be right, left, bottom, or back. It is field convertible for LP gas. So that answers the question from earlier. Here's the unit with a B cabinet on top for air conditioning. That's going to be field supplied. A little bit different here on the cooling side. We have a maximum CFM of 1450 CFM, and we range all the way down to 700. If we want to just have constant flow, you're looking at about 50% of the capacity if you just want constant flow. Every 50 CFM is a step. We'll show you that. Your capacity for cooling is 1.5 to 3.5 ton of cooling. And that's your stage breakout right there. So if you put in a unit with a 2-stage outdoor compressor, your first stage is going to be about 70% of the maximum CFM. And then at stage 2, we'll go up to 100%. And again, that is field adjustable. So the blower does react to static pressure, and it reacts pretty rapidly. We have a couple of condo complexes going in right now with GF200s, and we're actually doing 2 zones, 1 zone upstairs, 1 zone downstairs, with a 2-stage outdoor compressor, and we're tying it in with a zoning system, and they're working out extremely well. So one is actually has a mechanical room in the basement that it's in, and on the other job site, they spray foamed the ceiling and the roof, and the GF200 is actually in the attic. And the property owner originally wanted to go with mini splits on that job, and when I went to the job site with the distribution channel and the contractor, it was decided that the best application would be to install a GF200 in the attic and then duct down to the first level, the second level, and support the hot water. The building owner who was building the complex didn't know anything like this existed on the market, and it really reduced the cost of his HVAC cost. So he was happy. So we do have the ability to support up to 0.8 inches of water column. So no different than you would see with your typical furnace. So no reason to shy away if it's a typical furnace install and they either have or do not have air conditioning and the hot water heater is aging out. Again, this is a viable option for a job like that. On the very first slide, you've seen something on there. It said green furnace technology. And, what does that mean? Well, what that means is we can actually reduce the temperature swings within the house based upon how the blower operates and senses stages and remembers its last cycle. So we can reduce the temperature swings within the home. Because of that, we reduce green emissions and so on, carbon footprint, and that's what allows us to qualify to call this a green furnace technology. And we basically smooth out that line, as you can see in the diagram. Green furnace technology would line right up with that 70-degree column with very, very little waves. And it's got the same waves almost as a conventional system when you first turn it on, as it starts to learn the house. And then as it starts to learn the home, it will become much closer to the line that's marked 70 degrees, which is the line we're targeting. And we're not going to get those big temperature swings because it'll anticipate every time it comes on where it needs to start based on where it left off the last time it ran. And the next slide here, we'll just try to identify that a little bit more for you here. So basically what happens is stages 1 through 5, when demand ends, the fan shuts down because that's such a small demand. It doesn't need to, run at any level or continue to operate because it's about 50 CFMs per stage. So we're not really in a big hurry to, get back to that level. We can get there relatively quick. But if we go anywhere between stage 5 and 10, when the demand ends, the fan will drop to 50% of the total rise in the stages for 5-minute sequence. So what that'll do is that's going to take any residual heat off of the coil and put it into the house. And this is all what gets us closer to that green technology. And what we do is it will then remember where it was. So if it went to level 8, let's say, it will drop back down to level 4, and it will run there at level 4 with the blower speed at level 4 for about 5 minutes. That way, if there's another demand that comes in, the blower will already be on. We'll start to deliver that heat, and we'll cut down on the amount of temperature that was lost within the space. And we'll keep it closer to that 70-degree line we seen on the last slide. That's what this system does. It has the ability to understand what's going on within the home and how to make that homeowner feel more comfortable within the space. This right here, this is a big deal. This is a Dexstar blower. This is a 10-stage modulating blower. So we're used to seeing a motor and everything in a normal blower, and it usually is tucked in either the left or right side, which theoretically reduces the airflow for your return if you put it into the same side as that big blower is blocking the wheel. So this is an industry-leading technology. It's DC technology. So basically what we do is we put this together, and the motor, really, the two pictures you see over there to the right of that, just before the two blowers, that's basically the motor. Okay, this is the steps of putting the motor together. So it's a bunch of windings, and we basically run a wire to those windings, and we'll pulse the windings as need be. So this is where your blower motor would normally be mounted, right into the center. But what we have instead is we have a controller that mounts to the blower housing, the actual housing of the blower. And then you got your 4 arms that go in, that's holding the magnet. and then will pulse the magnets, and the wheel will actually rotate around that. So much different than anything you've ever seen. You know, if you've never seen the GF200, this is much different than what you see out in the field. You normally have either a belt drive blower or a direct drive blower, and the motor blocks a portion of the blower, or the blower wheel on a belt drive blocks a portion of it. Here, full open on the left, full open on the right. You can go right, left, back, or bottom for your return air and get the same airflow for each one of those takeoffs. That right there is the windings. You can see it. We have a blower that's, we removed the blower. That's the windings between the two hubs. There's the wire that's going in there. So we're looking at this from the right. And then that's the opposite side. So there is no blower motor housing mounted inside of this blower, which improves the airflow dramatically. All we're doing is we're getting right in there to where that little winding is in the center, and based on magnetic fields, we're rotating that around there, and that's how the blower will rotate. There's your controller. There's access to the controller. Pretty easy. It has a door that comes off that side, but if you're going to take your return air from that side, make sure you leave a flex collar or something on there so you can remove it. Act as an ECM. Yes, it's a question just popped up on the screen. Does it act as an ECM? Yes, it does. It pulses it. This is how we do our stages on that blower motor. It'll be based on timing and CFM and static pressure. So it's constantly going to try to fill a balloon, so to speak, as it ramps up through its 10 stages. The longer the heat demand is, the faster the blower will spin, because it thinks that because the heat demand is longer, that the blower must need to run harder and move more air to support what's going on within the house. So that's what it's doing. So if you needed to work on this, remember, this will be on looking at the unit from the front. The right side door by the blower will come off, and you'll be looking right there at the controller. So just a reminder, if you're doing it, fresh air from the right side, return air from the right side, you have to be able to get to that controller. To remove the blower, it will be left or right. So take either one of the doors off on the left or the right, and the blower will slide completely out. So if you're in tight quarters and your unit's going to have minimum clearance, let's say on the left side, and you're bringing your return air to your right side, make sure you can remove that right side duct to remove the blower if necessary. From a control standpoint, right on the top left, pretty simple to wire in. You got your fan, single stage of heat. You got your 2 stages of cooling on the right side. A maximum amp draw is 11.3, so we could run a 115 amp circuit. And the device you're seeing on the upper left there with the yellow wires, that's the flow switch for the water. And that'll wire right in so the unit knows when there's a flow. That goes into the R1 and 2 there, the R and the BK. And as water starts to flow through there, it'll report to the controller that there's a hot water demand, and that'll kick the unit on. As far as warranty goes, you have 2 options here. You have a basic warranty and an extended warranty. So out of the box, it's a 5-year warranty beginning from the install date. And you're going to go online to NTI boiler there, and you're going to register it. And that should be done within 6 months of the install. For the extended coverage, this will cover, repair, or replace any defective pressure vessel for the period of 8 years at 100% coverage, okay, beginning from the date of installation. To qualify for the extended coverage, the installation must be registered at www.ntiboilers.com under products and registration. And that's got to be done within 6 months of the installation also. And then down on the bottom here, it says for basic and extended warranties, it's 1 to 5 years for basic, 6 to 8 years. You add the extra 2 years for extended. Coverage will be 100%. So for the basic, it's 5 years, and for the extended, it's 5 years for all parts, including the pressure vessel. On the extended, it's just for the pressure vessel. And there's your coverage period, timing, and the information you need there for the warranty for the GF200. So for the guys that have seen this before, I hope this is a little refresher. For the guys that have never seen it before, I hope it gives you another tool in your toolbox when you're out there looking at jobs and have the opportunity to look at something different. When a homeowner has a need, you have the ability to look at it from a different perspective. Now that you can see we have some options as far as hot water, heating, and cooling all in one device. Any other questions on the GF200?
One question that came up was, can I adapt this to baseboard?
Well, it'd be a little difficult to put a second zone of baseboard iron. I mean, it probably could be done. I would just be very cautious of your BTU. You'd have to reduce the BTU on your air side and set your blower correctly, and you could put maybe a small zone of baseboard off of it, but you'd be cutting into the piping within the jacketed area. It's a little tough to get to. And you'd only be the maximum temperature you'd be running out there, Jim. They don't really run more than 160-degree water out there in order to achieve that 97% efficiency. So, you know, that, which would also make it condense, which is good. But that would be a couple of your obstacles. But you know, where there's a will, there's a way. It's water, right? We can do pretty much anything we need to do with hot water. Even if we took it off the outlet side and ran it through a plate exchanger or something, you could always put a zone off of that.
Yeah, just trying to reinvent the wheel at times.
Yeah. All right, if there's no other questions on the GF200, then I'm going to hand this off to Jim, and he is going to run with the TRX.
All right, everybody. So TRX condensing boiler from NTI. This is a new water tube style boiler. Basically, the water tube boilers that we've been using for quite a long time, they're all basically using the Giannoni heat exchanger, which comes out of Italy, which is a coil. It's generally in 2 pieces and has a very small water passage going through there. The burner sits inside the coil, and as it fires, the water as it's going through the coil is surrounded by that heat, and that's how we heat up the water. Generally, those water tube boilers have a very high pressure drop. So what does that mean? That means they must be piped in a primary, secondary fashion. Now, if you've heard of that term before and you're not 100% sure what that is, basically what we're doing is separating the flow rate from the boiler from the system side. So there's a loop specifically for the boiler that's separated by either closely spaced T's or a hydro separator. And then there's a separate flow rate on the system side. So that's called primary, secondary. So this new heat exchanger that NTI has developed has the ability on smaller BTU jobs, smaller GPM jobs, to possibly be piped without primary, secondary. Want to advance that, John?
Sure thing, Jim.
All right. So new performance, and we're combining a lot of technologies in one. So it's a very durable heat exchanger, as you'll see in a couple of slides. It's an 11-to-1 turn down, which we'll talk about a little bit more in a couple of slides. That means it's extremely efficient and has the ability to really match the heat loss of the home, especially when we're getting into those milder days with microzones cooling. And it also has smart conductivity, which means that we have Wi-Fi built into this boiler. So for the contractors who are normally doing service agreements with their homeowners, this is your way to be connected to this boiler and monitor it from your office. This is a way for this boiler to let you know, hey, it's time for a service call. I need you to come in here and check out the venting, check out the heat exchanger, make sure things are clean. And that's a really unique opportunity that you have with this boiler. You can see that it says 11-to-1 turn down. So what does that mean? This means this boiler can slide down from its high output down to an extremely low output. I know the 85,000 can go from 85,000 down to a low BTU output of 9,400 BTUs. So that's a big deal, because in all of our hydronic trainings, we're always talking about doing the heat loss, making sure you're matching the appliance to the load. And if my boiler can change its output based on what's happening outdoors, if the temperature drops, I got to give more energy into the home. The temperature rises, I need less energy in the home. And especially at this time of the year, when we're going to get days where we could be hovering, start the day maybe in the 40s and then get maybe to 60 by, 2 o'clock, 3 o'clock, you may still get a small zone calling for heat. And with an 11-to-1 turn down, the boiler can come down and get as close to that output as necessary. That makes for extreme comfort in the home. So and it also makes for extreme efficiency, because the chances of short cycling are dramatically reduced. It comes as a heat only, and also comes as Combi. It has a built-in ECM circulator and a diverter valve for the domestic hot water, and that comes on all models. Okay, and the indirect application, there's an internal diverter valve which eliminates the need for an indirect pump. That's a big deal too. Okay, John. So you can see we go from 85 to 120 in a Combi. I'm sorry, it's heat only, my bad. And the Combi version from 114 to 150. At some point this year, we will be launching the 150 and the 199 heat onlys. And then you'll also see a 199 Combi version. Qualifies for all the tax credits and Energy Star rebates that are out there. Again, that 11-to-1 modulation, that 11-to-1 turn down, we're the only kids on the street that have it. Now, there are other boilers that are 5-to-1s, there are other boilers out there that are 10-to-1s, but hey, we got an 11-to-1, so let's take advantage of it. High output ignition transformer. This is a big deal and very unique to NTI. This is a 10,000 volt igniter. This is the same thing that you would see on an oil burner. And we're the only guys that have it. So we don't have a little piezo igniter. We're going to light off every time there's a call. So that's a big deal. And that's especially relevant if you're doing a propane system. To move along there, John? Thank you. So here's a picture of this heat exchanger, which is different than the standard water tube heat exchangers that everybody is familiar with. First off, this is one continuous coil. So it's not two-piece coil, it's a one continuous coil. It also has the largest passageways you can see on the bottom. That means we can increase our flow rate, can create a lot of turbulence to make sure that there really should be no buildup of any type of deposits inside the actual coil. Gives us the ability to have a much lower pressure drop. All right, so we're the guys on the streets that have this. All right. Go forward, please. All right, so it's basically 150% wider waterway. All right, and again, it's a continuous coil, and we get a better heat transfer because we've improved the condensing service and we've increased that hydraulic performance. Move forward, please. So here's the inside of it, and both the Combi and the heat only have the same diverter valve. There is the internal pump. That is an ECM pump that is made from basically Taco. So it has a Taco ECM pump, very strong, very powerful pump. When we're in heat only, it's indirect ready, so the diverter valve changes position and we drive flow into that indirect. On the Combi side, you can see the small heat exchanger that's in there. And again, when we're making domestic hot water, the diverter valve will change its position and divert flows to the heat exchanger. So here, what we're showing you here is our capacities on the 85 and the 120. You can see that sliding scale, so how low these boilers can get to. all right? Because micro zones, this is something that John always talks about a lot in his hydronic classes, because some guys will say that, hey, I don't have to worry about sizing a condensing boiler because they modulate. Well, yes, you do, especially if you're going to have those micro zones. So this is a big deal. And you can see on the Combi side, the output at a 77-degree temperature rise, how many GPM will produce.
Jim, just to touch on that for a minute there, you're right. I do hammer that quite a bit on the modulating boilers. And what I always say to guys is measure up your smallest heat circuit within the house. That smallest heat circuit within the house, if you're measuring 580 BTU per every linear foot of baseboard installed in the home, you know, if you have a 10-foot or a 15-foot or even a 12-foot section of baseboard, if you do the math on that, you have to look at whatever boiler you're installing. And does the smallest zone in the house equal the lowest input rate of that boiler? If it does, you're installing the right appliance. If it doesn't, you're going to short cycle that boiler when that heat circuit is on. And that turns a condensing modulating piece of equipment into an on-off boiler when a condensing modulating piece of equipment wants to run to a low RPM and kind of run low, long input runs for steady state efficiency. So this is what Jim is saying here with the 11-to-1 turn down rate. That's like fantastic that we get an 11-to-1 turn down rate because of those smaller zones within a house. So that's what you have to look for if you're selling a homeowner, you know, a condensing appliance, so that we can take advantage of the efficiency that this can deliver. Thanks, Jim.
Right. A 12-foot run of baseboard at 580 BTU output, that's 6,960 BTUs. Okay, so if it's something that small, we really don't want to oversize our equipment. One other thing with this boiler, this is set from the factory at its air intake and exhaust for 2-inch piping. We can go up to 3-inch piping. So you can see at 2-inch piping, we can go a max of 100 feet for inlet and exhaust. And on the 3-inch, you can see a max of 150 feet. So that gives us a lot of flexibility. All right, so here's the trim and accessories that come with the boiler. All right, so this is the parts and pieces that will come with the boiler. Obviously, you're going to get the boiler and a bracket. You'll get the manuals, user manual, and installation manual, and a template so you can set it up properly on the wall. You'll get your condensate drain pipe, as you can see, a gas adapter kit. So if we're going from natural to propane, pressure relief valve. You're going to get 5.5 inches of 2-inch CPVC piping. This must be installed on the exhaust side of this boiler. We have to have that 5.5 inches of pipe right there in CPVC, because we can have our highest temperatures right at that point. And we have to have straight pipe. We cannot come off the top of the boiler immediately with an elbow. That's no good. That's going to cause us issues. So that comes with the boiler, must be installed. You'll get 2-inch vent screens and 3-inch vent screens, and you will get the outdoor sensor kit. Now, we go on a lot of these jobs with a lot of condensing boilers, not just only the ones that we represent, because we'll be there to help the contractor on the system side of things. And a lot of times we see these boilers installed, and we'll see a wire hanging out there on the wall, and we know right away that that was the outdoor sensor that somebody now disconnected because they never set the boiler up properly so it can modulate properly. The homeowner was thinking more of, it doesn't feel the same because I'm used to having all this heat come on all at once. This is something, gentlemen, that we do have to educate our homeowners about, that this type of equipment is different. And we are matching BTUs, we're matching heat loss as needed. So that outdoor sensor, if you want to make these boilers highly efficient, you want to make them sing, you want to use that outdoor sensor. If you don't, the boiler's just going to run at high, and then it's just a very expensive boiler, no different than cast iron. All right, John, going forward. All right, so here's our connection kit again. All right, so this comes with the boiler. The pipes are fully secured to the wall bracket for rigidity, and kit composition, like we said, tubes, plate, clips, and flow restrictor. So piping options here. Here's to show you what we're talking about because of this heat exchanger. If we've got flow rate that's 4.5 GPM or less, and the pressure drop through the whole system is not more than 10 feet or less, we do not need to pipe this in a primary secondary fashion. That means we're going to use the circulator inside the boiler for the whole system. So you have to be, this is incumbent upon you now to make sure that when you're either replacing boiler with this boiler or designing a system, that we don't go over these parameters. So for the people that are on this class today, you've gone through some of our hydronic classes, hopefully. If we're going to maintain a 20-degree delta, 4.5 GPM, that's 45,000 BTUs. 10 feet ahead is about 166-foot long loop. So that's still a pretty decent sized home, definitely a condo or a small apartment. But if we go above those GPMs in head, then it must be a standard installation where you'll see it on the left-hand side where you'll see the closely spaced T's, and that is in primary, secondary. If you intend on zoning with circulators, then it definitely has to be in a primary, secondary piping. All right, so here we're showing you, again, if I'm going to do a bigger BTU job and I'm going to have an indirect, we do also have to pipe this up in primary, secondary. Okay, so know your system. It's in there. Now, this is something that we're very sensitive to because we want to make sure nobody has an issue out there. So you do need to know your system. So really the lowest flow rate would be 2 GPM. Again, at a 20-degree delta, that's 20,000 BTU. So if we're at that lower flow rate, we have the possibilities of overcoming a little higher pressure drop. And as the flow rate increases, that feet of head comes down. So we show you the column for a Combi system. And when you see CH, that means central heat, heat only. So that's just making heat, no domestic hot water, or heat only with domestic. You can see the column there for the amount of head that we can overcome based on GPM. So here's the hydraulic block in the Combi version on the top and the heat only version on the bottom. So number 8, that is the sanitary plate heat exchanger. That's the flat plate heat exchanger. That's where we're going to make our heat transfer and make our domestic hot water. So the only difference between that Combi version and the heat only version is that heat exchanger is now not installed on the heat only side, but we have an external bypass. Everything else is basically the same. Now, comes to venting, you got a lot of different options. Again, up to 100 feet with 2-inch, up to 150 feet with 3-inch. We can do PVC, we can do poly, all right? We can do CPVC. Again, you're gonna get that 5.5 inches of straight CPVC that must be installed on the exhaust. Then after that, you can adapt to what your venting material is going to be. We recently just did a class a couple of days ago that Anthony Tassi did on condensing boilers and hydronic systems. He did an excellent job showing the importance of using the right materials for venting and making sure that your flue gas temperatures are within the range of that venting material. So PVC, even though it's inexpensive, is generally not the best for venting. Though we can use it, you must stay within the guidelines of that temperature rating for that product. So polypropylene is really your best option. So we can do a tube pipe version, as you can see. We can have that mushroom adapter on the side of the house. We can go out concentric, either sidewall. The next screen, I should show you a roof termination in concentric. I guess not, but we can. All right, so now the service side of things. It's pretty simple to do the service side, and there's a lot of space in here, so you do have access to the components. and they're bayonet quick connectors. So that eliminates the need for brazing and soldering inside the unit. So the front panel where the control is, that'll swing down, so it opens up so you have more serviceability to all the components. Now, we have a very robust flame sensor and igniter. We have also that high voltage transformer you can see there on the top, and on the bottom the silencer. That keeps us running very quiet. So this is a very quiet system. I've been on jobs where once the startup happened and everything was going well, homeowner walks in and says, well, when is this going to be running? And you know, it's been running for like a good 10 minutes while they were standing there. So very, very quiet system. You can see our premix on the left-hand side there of how we mix our fuel to gas ratio, air to gas ratio, pardon me.
Yeah, they're good service points, Jim, for maintenance there, right? We got to make sure that Venturi's clean and you know, free of dirt and debris, and we want to check those during annual maintenances.
Absolutely. One of the things we have found a lot of times, especially with the igniters, if you inherited a job, maybe you've taken over service on a particular install, and you notice that there's multiple igniters laying on the ground. That's a venting issue, gentlemen. Those igniters fail based because the venting is not correct, and we're sucking in some exhaust, we're bringing in moisture, and we end up killing those igniters. So as we always say, a good install will stop 99% of your maintenance issues. But the maintenance here is pretty simple. We should have a couple of slides to show that. So you open up and you remove the junction box, so that black triangle is showing you where the junction box connections would be. Then you unhook the junction box support, as you can see there on the right-hand side. Next, yep, John's going to use the highlighter to show that. Okay. Now all the wiring is Molex plugged in, so as you go to the next slide, John. All right, then we're going to remove that silencer on the bottom. We remove the gas piping. All right, so as you can see on the right-hand side, again, not very difficult, and you have a lot of room. Next slide. Now we're going to remove the combustion assembly, and it's a matter of 4 screws. I'm not sure if they're Torx or not. Do you happen to know, John, by the way?
I think they are Torx, Jim.
All right, so that's a Torx, so make sure you got a Torx kit that fits. Then we would remove the combustion assembly that you pull that towards yourself. All right, now again, any wires that you also have to unplug, they're Molex plugged in, so that's pretty simple, and they're color coded, so you're going to put them back. You're going to look inside there because there's the inside of the heat exchanger, and you're going to look at the back wall. That's the refraction plate, and you want to make sure that that's still intact, that that's not damaged. If that was damaged in any way, shape, or form, you would have to replace that also. So now we can pull out the igniters and inspect them if needed, but if at this point, on the left-hand side, if everything looked good, everything was clean, you sprayed with your solvent, could be a simple green and water type of situation, you spray along the inside of the heat exchanger between the spacing on the pipings, and but a plastic brush. Scrub it down, rinse it out, make sure that the condensate drain is clear. If everything looks clear, you didn't see a lot of what would look like coffee grinds inside there or none at all, then you know your venting is spot on, everything is good. At this point, you can put it back together, you know, check for any gas leaks or anything, and then start the system back up. If you feel that you do have to change that igniter and sensor, you want to take out the 4 screws that you can see on the left-hand side, 2 screws for the igniter, 2 screws for the sensor. And now you can remove the burner assembly. You would take that towards yourself. And if you need to replace that, you can. If you needed to do that, you do want to replace the gaskets that are behind the burner assembly. Now, maintenance is an interesting thing. A lot of guys kind of shy away from doing this. And this is something that must be put forth to the homeowner when you install this type of boiler. Number one, most of these condensing boiler manufacturers are not going to warranty the equipment if no maintenance was done. So if there was a problem and it's due to a lack of maintenance, there's no warranty. And sometimes the contractors will say to me, well, Jim, the homeowner doesn't want it. They don't want to pay for a service agreement. Well, it's up to us to educate them, gents. We have to do that. And the reason why is no homeowner would drive a car and not maintain it. We wouldn't drive our trucks every day to do our job without maintaining them. This is not cast iron. This is completely different equipment. It must be maintained. So
And
either
this boiler, Jim, this boiler, if they use the Wi-Fi on this boiler will actually email them and tell them the boiler is due to be serviced. And that's pretty powerful to call the homeowner and say, your boiler just called me and said it wants to be serviced.
Sure, absolutely, absolutely. The boiler will also call you to say, hey, we're having an issue, and you may be able to make a control adjustment from your office instead of sending your tech out there. Or if you do have to send your tech out there, he already knows walking in because of the Wi-Fi capabilities of what that issue is. So he's not going to waste time trying to figure it out. He's going to know what that problem is and will be able to make that correction. So take advantage of maintenance. Maintenance is a money maker for you. It's not a hindrance. It's a great way to grow your business. It's a big deal. All right. I don't want to go off on a tangent on there. I tend to, so I apologize. The control is very straightforward. Since this is a Canadian company, CH, you're going to see CH a lot. That's central heat. That's what that means. So we basically have an on-off button, the domestic hot water adjustment button, as you can see, plus or minus, and that is the icon is a faucet. There's the menu button, so you can change the menu. We have a history button. A lot of times you guys would be told by the homeowner, oh, this problem happens constantly. You can check that history button and see that only happened once. All right, so that'll keep things honest. We have a reset. Anytime you make any changes in your programming, you can hit the OK button, the escape to get it back into service. You have the ability to change your temperature adjustments, and it's basically your plus or minus. Okay? Very simple control. Now here again is the Wi-Fi capability. It's on board. As a contractor, you would have to sign an agreement with NTI that you're not going to do anything, what's the word I want to use? Bad. If Mr. and Mrs. Smith haven't paid the bill, you can't go in there and shut them off, all right? But this is an opportunity to help you build your business. You can set this up that you get all the notifications. Mr. and Mrs. Smith do not. They could if you wanted to set it up that way, but I think it's in your best interest to set this up that you get all the notifications, not them. We do a lot of classes. We talk to a lot of contractors, and most homeowners are not handy. Most homeowners are not going to be doing any of this stuff on their own. This type of equipment going forward, at some point, maybe before my career is over, but definitely after my career, this is going to be a standard because at some point, the rules and regs will say that cast iron will be done. And this is the type of equipment we have to be putting in because of efficiency reasons. And this maintenance is a big deal. So to be able to get alarms from the boiler itself, hey, it's going to tell you that you're scheduled for next week to come in there. That should give the homeowner a lot of peace of mind.
Yeah, the other nice thing with that too, Jim, is the outdoor sensor. How if it doesn't have to be wired, you can use if you're using the Wi-Fi, you can use Google Temps, and Google Temperature will tell the boiler what's going on outside without running a wire to the outdoor sensor. So that's a big deal.
Awesome, awesome. So if you're going to do something like that, gentlemen, or you're going to use this Wi-Fi, one thing we got to make sure is that there's a strong signal at the job. That would only cause havoc in hell if there wasn't. All right, what do we got next? All right, so again, remote diagnostics for the professional. You can set that up so you're always close to the equipment, always close to your customer. All right, that gives you the 24/7 monitoring. Okay, effective time management and cost planning. You guys know how much it costs for you to send out one of your techs on a service call. And if we can send him there, but he knows going in exactly what he has to do, that's going to manage his time. That's going to make it very efficient for you and cost effective. It's a great tool. And again, peace of mind for the customers. So this is something to talk up. You're going to sell this equipment. This is something to talk up and let the customer know that you have the ability to do this. This will make you stand out from your competitors. To me, I feel that's a big deal. John, anything to add for that?
No, I just think it's definitely anybody can go in there and offer a BTU, and you're offering a BTU with a service. It's we take it for granted because we know how to fix heating equipment. We understand mechanical devices. A lot of homeowners, when you start talking boilers about them, it's like you're talking in a foreign language. So if you can go in there and say, listen, this boiler is going to let me know when your service is due. I could always check a problem before I have to dispatch someone to your house. I mean, look what we got going on today. We're doing remote training online because of this pandemic. If someone called with a problem and they had this NTI TRX in their basement, we could go online and look at that system, or we may have already been notified from the boiler that it has a no heat situation or a no hot water situation. So there's a ton of benefit here, and it just makes you represent your company better to the homeowner to say, yeah, we can do the install, we can monitor your system, and we can service your system and fix your system when and as needed. So yeah, it's peace of mind. A lot of people are looking for peace of mind. They're not as, the generations today, majority, I don't think they're as mechanically inclined as, my father
No.
and past generations. So this gears right towards that new generation.
Right. Most homeowners, I can take you to my neighborhood, Jens. I'm in North Jersey, Passaic County in Wayne. And everybody in my neighborhood, they want one person to call. There's only a couple of us on our street that actually do, home maintenance. Everybody else wants somebody to call. And if part of your business is also plumbing, hey, that somebody is going to be you for the boiler, for just general plumbing. Great way to build a business. All right. Any questions on the TRX? We're very excited by this product. We hope you give it a try out there. I think you'll be very happy. Anything on the GF200?
I'm not seeing any questions, Jim. So
We killed it.
you did awesome. Yeah, you did awesome.
All right. So if there are no questions, we hope you come back later today for our next webinar, which is going to be Fujitsu rebates and contractor programs at 1 o'clock. A lot of programs. Sorry about that, I got muted. So I hope you come back for that 1 o'clock class where you can learn about the different programs and rebates in the world of Fujitsu. Thank you very much for your time today.
All right, I got no other questions here, Jim.
There was something here.
Can you use propane? Can you use propane? They're all the ones you had. I didn't see any on my end.
Okay, very good.
So,
all right.
Just waiting to see. There are 14 guys still in. I'm just seeing if they are checking out, if there's anything. Nothing there. Does a GF, will it work with a variable speed condenser? Yeah, that's old. That's an older one. They asked that earlier.
Yep.
Here's one question. Let me see what this is. Does the installation manual talk about baseboard? We answered that one. That's it. That's all we got.
What we got?
All right,
All right.
over and out. See you.
Over and out.
Edit your name. I see it there. All right, end webinar.